Okay, so we're going to do a horizontal motion problem today, 3.4b. It's quite a bit different than vertical motion because it's really hard to graph the horizontal motion as much. But what this does is the horizontal motion allows us to explore and understand the uniqueness of position, velocity, and acceleration, and how they come together. Don't worry about that flash. Hopefully everything stays on, or maybe that's just my projector. And also how these physical quantities connect and explain the motion of an object. What do you mean about explaining the motion of the object? Well, I'm talking about when's it moving right, when's it moving left, and where does it stop? When is it speeding up? When is it slowing down? And vertical motion is pretty boring because you throw something straight up and it comes straight back down. Nowhere have I ever thrown a ball in the air and on the way down it just kind of stopped coming down and it went back up for a while and then it came back down. So what comes up, goes up, comes down. Well, left, right, left, as I'm horizontally moving, things can get a little bit different on me here as I'm moving along with that. So what we're going to do is we're looking at this first example here, obviously, okay? An object moves along a horizontal line, and its position or its displacement, okay, its position or displacement at any time t is given by h of t equaling 1/3 t squared minus 2t, or t cubed minus 2t squared plus 3t plus 1, where the displacement is measured in feet and the time is in seconds. Well, what we're going to do to make sense out of this first is we're going to graph this horizontal motion on your calculator, and we're going to graph it as a parametric. So grab your graph, and the difference today is now I'm moving horizontally, I'm not moving vertically. So make sure you have your calculator. Grab your calculator, open it up, open up a graph, and within the graph we need to make sure we are changing the graph entry, and we want to graph a parametric, okay? And this parametric function, because x is my movement, it's moving horizontally, x of t is going to be 1/3, and we have to use t for our parametrics, t cubed, that's my variable, minus 2t squared plus 3t plus 1. Okay, that's my horizontal parameter. My vertical parameter, okay, because I'm moving horizontally, I'm going to do what I did with my horizontal parameter yesterday. I'm just going to call that 1. And all that's going to do is that's going to move, so I'm not seeing this particle actually move along the x-axis. I'm going to see it moving just above it, kind of parallel to the x-axis. And again, I need to change my t here. I need to go from, my directions tell me here, use a window for t from 0 to 6. And we're going to make the t step, okay, 0.1. And there's a reason why. Whoa, stupid thing. Now I got to go back. Now I got to re-enter this thing. And this is so annoying. So I'm going to say 1/3 t cubed minus 2t squared plus 3t plus 1. Minus horizontal parameters would be 1. And of course my screen just went out for a second. And I'm going to go delete, delete, delete. And I got to come over here. And I'm going to make this parameter delete. Okay, I want my t step to be 0.1. And the reason for that is because this was a strategically picked problem that is going to show us a wonderful horizontal motion. So I can move that over out of there, and I should be able to get that. Now I also need to change my windows here so I can see this. So my window zoom, and I'm going to change the windows here a little bit, not from what it says on your sheet. I'm going to go from -1. And I want my x max, I don't want my x max to stop at 8. I want my x max to stop at 25, okay? And I'm going to go by 1. Actually, yeah, I'll leave it at 25. and my y minimum is going to be -1, y maximum is going to be 2, step of 1, and then I'm going to come down and I'm going to say OK. And the reason being, I can see where my path is going to end, and I just like how it's going to end. Now, I don't know about you, but this parametric equation that's on here is really bothering me. So if you ever want to get that, you highlight it, you hit delete, and it just takes it off. Or you should, no, I don't want to delete everything. Okay? No. So I just want to make sure that okay, I think I got it back here now. So on my Windows, this thing goes all wonky on the board all the time. So now what we're going to do is we're going to use trace to get the important points. Now this is going to be horizontal motion. Now I'm going to quickly go, and when we get points, we're going to write our points right on here. Okay, and remember our horizontal is 1/3 t cubed minus 2t squared plus 3t plus 1, and my vertical component's going to be 1. Now we're going to come back to the calculator. We're going to trace this, and we're going to find important points, meaning where did the particle start, where did it end, and where did it change directions? And we're going to label them on the graph with a t value and an x value. Okay, and this little spot that you have to graph, you're not going to graph anything there yet. We're going to make these points, and then you're going to be able to see where they are in a minute. Okay, so I'm going to come back here. I'm going to grab my calculator. I'm going to come onto my calculator, and I'm going to go to trace. Okay, trace my graph. Now, right here, I can tell my time. My time is 5.45829, and its position is 11.99. So now my position, remember, is the x part. And where am I going to start? Well, hopefully we get, if we put a 0 in for 0 time, we are starting at 1. Okay? So what that means is when t equals 0, my position equals 1. Okay? Now, what's the next thing we're going to be looking at? We want to know, when does this thing change direction? Where does it start? Where does it stop? So what we're going to do is, as you use your right arrow, okay, you're going to use your right arrow. Watch, it's moving right, moving right, it's moving right, moving right. Keep pushing it slow. It's still moving right. It's just not moving as fast. Now, when I keep going, whoa, it went back. So where did it stop moving right? Right there at t equals 1, my position is 2 1/3. Okay? So we're going to come back here. This is where it started. T equals 1, x equaled 2 1/3. Okay? Where did it change direction again? So what I'm going to do is I'm going to come back to my calculator here, and I'm going to keep going. Now I'm moving left, moving left, moving left. It's weird because I'm pushing the right arrow and it's moving left. And it's coming in there, and I see right about here, 2.93. Oh, now it's coming back, right there. There it is. T equals 3. I am back at position 1 again. So I'm going to come back here. I'm going to log that and say at t equals 3, x equals 1. And I'm going to keep going with my right arrow back on my graphing calculator. And I'm going to keep going right. Now watch that sucker. It's really making up some distance there. And then kept moving right there. It stopped. Finally at 6, where is my position? My position at 6, I can see is down there at 19 because I'm going 0 to 6. Okay? So I know that I got to take my board. I'm going to say when t equals 6, x equals 19. It gets all the way out there at the edge. Now, if I came back and I held my arrow down, okay, I can kind of see, I don't know why it stopped there and didn't go, but I can see if I hold it down, left, right, left, and it goes to the end, back to the start, right, left, right. Hey, isn't that kind of cool?
right, left, right, right, left, right. And I can see when it's kind of speeding up too. Moving slow, fast, kind of going all over the place, okay? So what we're going to do now is, still don't copy that, what we are going to do next is we are going to come on here, we're going to label these points on our graph, okay? This is what you want to do in my book. Now remember, my y, I changed to, my y is going to be my time, so it's horizontal. So before I do that, I found those. Now in my next screen, okay, what I'm kind of looking at, and what I spit it out, Kruger. What I want to do to actually see my right, left, right really nice in my calculator here is what I'm going to do is I'm going to go to tab just like I did yesterday. I'm going to go up to the equation I had. Now I'm going to make my y parameter, I'm going to make that into my time. And what this is going to do is this is going to graph me a non-function because, well, not really a non-function, but it's going to graph my horizontal movement that I want to see. And I still want that at a 10th. And I'm going to say enter. And obviously I need to change my window because I need my window to go 0 to 6. And I can see I'm going right, I'm going left, and then I'm going right. So I can kind of see the movement of this little thing. Okay? Now this is the part I want you to sketch on your graph above there. So what you would do is you'd come back here to the notebook, and what we just did is we made our y time here. So here's my time, here's my position. Okay? So what we are doing is we're graphing a couple. We're saying, hey, I'm starting here at, when time is 0, I'm starting at 1, so I'm starting right here. I'm changing direction at 1 and 2 at t equals, gotta wait for my notebook to come back. So at time 0, now at time 1, my position is 1, 2 and a third, so my position is somewhere right about here. Then at time, because this is time 2, 3, my position at time 3, it's back to position 1. And then, whoa, I'm off a little bit there. That's all right. That's okay. Moved everything. It'll be all right. Get back there. That's close enough for government work. And at t equals 6, 1, 2, 3, 4, 5, 6, I'm all the way out here at 1, 2, 3, 4, 5, 6, 7, 8. I'm all the way out here at 19. And I'm just jumping this out here to 19. So I can see my particles moving right, and then to the left, and then to the right. So it's not quite as smooth as it is in my calculator, okay? However, that doesn't matter. So those are the important points I'm going to label. Well, I have the luxury that I can kind of plant in post. Now notice this guy, I'm only out to 8. I didn't take it all the way out to 19 here. That's not a big deal. So coming to my next page, what we're going to do is we're going to read that graph. Now notice I have all those points. This guy is way out here, t equals 619, because I'm still at 8, okay? But basically what we're doing here is we're looking and saying, hey, during what time intervals is the object moving to the left? Well, obviously, this is right, this is left. Okay, that's a bad R. So when am I moving to the left? The time intervals. So I'm moving left from what? T equals 1 second to 3, because I can see right here, this is when I'm moving to the left. Object's moving to the left. When's it moving to the right? Well, I'm moving to the right from time 0 to time 1, union with time 3 until time 6, okay? So that's where I'm moving right and I'm moving left. Now it's kind of weird, and what we're going to do is we're interpreting as a parametric, and we will be looking at this as a function and it's not going to be graphed horizontally. We're going to graph it as a function at the same time, okay? So the next question, find the functions for the velocity and the acceleration of the object. Well, it'd be nice if I came back here and I'm looking, this is my position, right? So my v of t is going to be the derivative of this. So 1/3 times 3, so that goes away and I get t squared. 2 times that gives me negative 4t plus 3. So there's my velocity function that I'm getting, right? Of course, we're going to write that over here. So my velocity function is t squared minus 4t plus 3. Now remember, because that's velocity, don't forget, that's going to be feet per second. Okay? Now this is a velocity function for my object. Well, what's the acceleration? Well, acceleration is derivative of velocity. So wouldn't my acceleration be 2t minus 4? But now, of course, that's feet per second, or feet per second squared. Well, this is a little different. We don't have a constant acceleration anymore, okay? Now, at what t value, at t equals 4, we're asking at t equals 4, is x of t, is the position increasing or decreasing? Well, let's go see, where is t equal 4? T equals 1, 2, 3, 4, because I'm looking at it here. Is my position increasing or is it decreasing? Well, my position is increasing at what rate is it increasing? Well, and I can see, because it's increasing, my displacement is moving to the right, and here I'm at my 4 there. Okay. 1, 2, 3, 4. That's my. Oh, I'm a little high. I don't think I'm going to be able to get that guy. Let me get him there. There's my t equals 4 because it's off my t-axis on the right. Okay. So is my function increasing? Yeah, it's going up. I can see my position at t equals 4 is moving to the right. Therefore, it's increasing. What rate is it increasing? Well, wouldn't that just be finding v of 4? My velocity of 4? Well, that is what? Plugging 4 into my velocity gives me 4 squared minus 4 times 4 plus 3. Well, that's kind of nice. That's 16 minus 16. That's going to equal 3 feet per second. So it's increasing at a rate of 3 feet per second. Well, let's use the velocity function now to find when the object is changing direction. Well, okay, how are we going to do that? Okay, and I guess what I should have kind of looked at here before we got there is explained a little something, and I can still explain it now, okay? Because I can see when my function's moving right, moving left, moving right, and I can see that based off of this previous one that I had here. This is where I was going to do it. Squirrel, forgot. So here, oh boy, like, okay, so from here, I move to the right, right? From, when did I move to the right? From 0 to 1, I moved right. Then, right here, I'm not moving right, I'm not moving left, I stopped. And then I moved to the left, right here. So then I went left from 1 to 3. And then from 3, now remember, I'm pulling my time here. My time is my y-axis, here's 1. So from 0 to 1, I move to the right. From 1 to 3, I move to the left. Now, from 3 until way out there at 6, no, left, right. So I can see my object, and we could see that where it moved right, left, right, and it went all the way out there. So I can kind of see that when I put this motion into a parametric. And use the velocity function to find when the object changed direction. Well, we just said it changed direction at 1, changed from right to left, and then it changed from left to right. Well, how would I find that? When is it? How am I going to do that? Well, how do we find that? Those are kind of weird looking points, aren't they? Granted, they're horizontal, but wouldn't we, to use our velocity function, wouldn't we just set our velocity function, which is t squared minus 4t plus 3, wouldn't we just use that, solve it for 0? Well, that's 0. Oh, that's a nice factorable problem. And what is that? That's going to be t minus 3, t minus 1. So, oh, well, look at there. At t equals 3 and t equals 1, I changed direction. That's when my velocity was 0, okay? So I can see that. T equaled 1, t equaled 3, because that's my t-axis over here. So position is 0. So from part C above, copy the intervals in the correct order, left, right, left. Well, I just did that before, okay? We went left from 0 to 1. No, we went right, sorry. We went right. Then we went left from 1 to 3. Then we moved right from 3 to 6 again. So we went right, left, right. What we're going to do is select any number inside my first interval between 0 and 1. Now, I know from previous experience, if I ask a student to pick a number between 0 and 1, they typically pick a half, okay? What we're going to do is we're going to plug that half into our velocity, and we're going to see what is the velocity. Well, my velocity function is what? 1/2 squared minus 4 times 1/2 plus 3. Well, isn't that 1/4 minus 2 plus 3? That looks like that's 1 1/4, which is 1.25 for the decimal freaks, but that's feet per second. More importantly, is my velocity, is it positive or is it negative? And I can see this velocity is positive. Well, check it out. That's kind of odd. When my velocity is positive, what's the direction I'm moving? I'm moving to the right or towards positive numbers, okay? Well, let's come down here. Let's pick, in the next interval here, let's pick a number within the interval from 1 to 3. Previous experience tells me everybody's going to pick 2. So if I put 2 in there, I know 2 squared is 4, minus 4 times 2 is minus 8 plus 3. Ooh, that gives me -1 feet per second, okay? Bottom line, what am I looking for? When I'm moving left, my velocity is negative. And I can kind of see that in this graph because when I'm moving left, velocity is negative, I must be moving towards the negative or towards the lefts in a horizontal motion problem. Well, here, let's make a guess. What do we think? We're going to move to the right. Well, let's pick one in this interval. Well, we picked 4 in the previous, and we picked 4 right up here. 4 is within the interval from 3 to 6. So let's do that. Oh, that was 3 feet per second. Bottom line, that was positive. Oh, what do the signs of these tell you? Well, the signs of my velocity give me direction. They give me the direction of the object. When velocity, when v of t is positive, I move right. When v of t is negative, I move left. Okay? Now, technical question, what's the total distance traveled by the object over 0 to 6? Now, total distance traveled, okay? Not displacement. Meaning, if you came to school and you're like, oh crap, I forgot something, and you turned around halfway, and you went back home, you traveled a total distance, did you not? You didn't travel a total distance of nothing because you went forward and back. Total distance is adding all of my sums together. So when I'm looking here, from time 0 to 1, I traveled what? I went 1 1/3, didn't I? So I went 1 1/3. Then between 1 and 3, I went back to 1. Here's my position, 2 1/3. If I started at 1 and I went to 2 1/3, I traveled 1 1/3. Well, then if I'm back at that 2 1/3 and I go back to 1, didn't I just go another 1 1/3? Okay? And then I'm at 1 and I travel out here to 19. Well, that would be plus 18 more. Okay? So when I come down here, if I take my 1 1/3 plus 1 1/3 plus 18, that gives me what? 20 2/3 feet is my distance traveled. Now, it's not my displacement. If you were asked, and you will be asked, what is the displacement of the function or of the object? Well, displacement is the difference between where it started, and where it ended out here at 19. My displacement, if I started at 1 and I ended at 19, my displacement, which they didn't ask me, don't confuse these though, my displacement is 18 feet. But remember, I kind of left home and I was on my way to school and I'm like, oh crap, I forgot to pick something up. So I went back home and then I went all the way to school. I still traveled 20 2/3. My net distance change from home would be 18 feet. So make sure total distance, displacement, they're asking for two completely different things, okay? So now what we're going to do is we're going to come here and we're going to type this same function in, except we're going to type it into the graphing portion or into the function mode of the calculator. So I'm going to come here and I'm just going to say add a page and I'm going to add a graph, and now I'm in f of x. I want to type this as a function in here, and I want both my position and velocity. So I'm just going to give it the old control divide. Hold on. I'm going to give it the old control divide so I can get my 1/3. Whoa. Oh, it irritates me. Now I'm onto a new computer and everything changes for me. And that's going to be x to the 3rd. And then I got minus 2x squared. I'm going to say plus 3x plus 1. And right away, well, if I hit enter, there's my displacement function, okay? And I don't want that on there, so I'm going to get that off of there. But I'm also going to graph my my velocity function, and I know my velocity function is x squared minus 4x plus 3. So you have both of these. Red is my velocity, blue is going to be my position, okay? And we're going to change these windows. So I'm going to say menu, window, window settings, and this is telling me use 0 to 6 because now my x is my time. Now I'm graphing time as a position as a function of time, okay? And I'm going to take my y's. I'm going to go from -4 to 12. That's fine. And I'm going to go 1. And if you don't like the 12 and you're like, hey, I want to see it at 19, okay, put 19. Really doesn't matter. So this is the position of the function as a function, the position of the object as a function of time. And it's not dictating my horizontal positions, okay? Now, what I'm going to do is I'm going to change this from 9. Why did I put that at 9? That's supposed to be 6. And then I can kind of see my 19 out there. That's all good. Doesn't really matter. I don't need to see way out here. So then we're going to come back here to the notebook, and you're going to copy both of these graphs right into your notebook space right there, okay, on that graph, because now we're going to use this graph after you have it copied. So I'd hit pause, you copy it in there. Now we're going to use these two graphs, okay, and we're going to interpret these graphs and look at what is happening with our function, okay? So now, please don't forget, because it's in function mode, now x is time and my y is position, the way you're used to reading a graph, okay? So the first graph I'm going to look at, I'm looking at both of these at the same time. Made a funny position. And the points where the velocity is 0 and the points where the velocity function is 0, what is the displacement function? Well, here's my velocity, I'm at 0. Here's my velocity, I'm at 0. What are the positions, okay, or not necessarily the positions, what do I notice about my position function at these points? Ooh, they're flat. Even more than flat in this case, what are they? They are max or mins in this case, okay? So bottom line, my velocity is 0 when my displacement is flat, okay? Well, what are the intervals where the velocity is positive, the displacement is what? So, well, if my velocity is positive, and I'm going to change up some color here, my velocity is positive, right, because I'm above the x-axis. Here, my velocity is positive, correct? What do I notice about my function? What do I notice about the displacement? Well, what's going on? I'm going to do the purple guy. What's going on right here? What do I notice? When my velocity, when the green is there, what is the purple doing on position? Well, yeah, you guessed it. It's increasing. Okay? The intervals where velocity is negative. Here's where my velocity is negative. Okay? Well, I'm going to go and say, well, if my velocity is negative, what's going on with my position? Or my displacement. Okay? Well, that's a connection we made before. That's the same connection between a function and its derivative. Okay? Now here's the hard one. We want to be able to tell when the object is speeding up and when it's slowing down. Trace the displacement function and see if you can guess when the object appears to be speeding up and slowing, when it appears to be slowing down. Well, yesterday, we had a great day in class for one of the first times. Well, because we're finally back to school. And let me erase this. And get rid of that for a second. And get rid of that. And what I'm going to do is say, okay, well, when was it speeding up? Or when is it speeding up? Well, did we or did we not? I really shouldn't have done that. I'm taking it back. Put it back on there. Okay. So what did we notice here? Well, yesterday, we did learn, if I'm looking at the position, okay, on my displacement function, here's my displacement function, d of t, which is really x of t, okay, well, here I had a max, here I had a min, and didn't we yesterday look and say, okay, speeding up. It was speeding up when my curve was getting steeper, and it was slowing down when my position curve was getting more flat. Or I don't like more flat. I'm going to say less steep. Well, if I'm looking at my steepness of my curve, what is happening from 0 to 1? Is my graph getting steeper or is it getting less steep? Well, looks to me like it's getting less steep. So I'm going to say I'm slowing down from 0 to 1 on my position. Okay. Then what happens? Ooh, it's getting more steep, but then it gets less steep. Whoa. What's right in the middle of there? It's getting less steep or more steep, right? And then it's getting less steep because it's coming back to 0. Ooh, look at that guy somewhere right in there in the middle. What was that? Point of inflection. Oh, that looks like that's at about 2. So I'm going to say my curve's getting less steep, or actually it's getting more steep because my tangent lines are getting more positive, more negative there. So I'm going to say I'm speeding up from 1 to 2. And then from my 2, now they're getting less steep. So let's chuck this little guy over here from 2 to 3. And then from here on out, ooh, it's getting more steep. If it's getting more steep, it must be speeding up from 3 to 6, okay? Now remember, speed is defined by the absolute value, okay? If I did that, notice, here's my velocity function, and now I'm taking the absolute value of that velocity function, that's this black one, okay? When is it speeding up, slowing down? This is really easy to see when something is speeding up and slowing down. Well, if my speed function's decreasing, I must be slowing down from 0 to 1. And then it increases to that little maximum point there. So from 1 to 2, it must be speeding up. Then it decreases again. So union 2 to 3. And then from 3 on and on forever, okay? From 3, not on and on, to 6, because that's where we're stopping, it's speeding up, okay? So these are exact intervals now off of my absolute value function. And granted, I kind of let you get in here, but notice concavity is also telling me if something is speeding up or slowing down, because concave down, decreasing, concave down, speeding up, concave up, and decreasing, slowing down. But just look at the steepness of the curve of it, okay? Now we're going to come in to the culmination of it all. I said it usually comes together at the end. Is this what I wanted? Yes. Now take a look at the velocity curve again. So here's my velocity curve, okay? And I have these separated so you can see them nice in here. Okay, can you make a statement about how you could use velocity to determine when the particle is speeding up or slowing down? Because we already know right here from 0 to 1, it was slowing down, right? Okay, so why was it slowing down? Oh, because that's when my v of t, when my velocity function is moving toward 0. Now, remember, when I'm taking 0, I'm thinking x-axis. So my function's moving towards the x-axis. Therefore, I'm slowing down. Ooh, check it out. From here, from my 2 to 3, oh, again, I'm moving toward the x-axis, which means I'm slowing down. When I'm speeding up is when my function on my velocity graph, when v of t is moving away. Whoa, that's a bad spelling. I'm bad at spelling, but that's really bad. Away from the x-axis. So, check it out. From 1 to 2, yeah, I'm moving away from the x-axis. I'm speeding up. I'm going to I'm going to say I sped, oh, come on, maybe. I sped up here, and then from 3 out, I'm moving away. I speed up here. Notice I'm moving towards the x-axis. I'm slowing down, and I'm moving towards the x-axis, slowing down. This is on my velocity curve, reading from left to right only, okay? So now, the last page, culmination, because we have to be able to look at a graph, and we have to be able to say, how do I know if I have the position? When the heck, looking at my position function, when is it speeding up? Well, I'm speeding up when my tangent lines, when my slope is increasing. When my slope is increasing, okay? Tangent line's getting steeper, tangent line's getting steeper. When am I slowing down? When my slope is getting less, when my tangent lines are getting less. Here, tangent lines, here they're on the top, here I had to jump to the bottom, and they're getting flatter and flatter. So that is slow down, and then the red one, that's speed up, because I have getting steeper, okay? Position is talking about the steepness of the curve, speeding up, slowing down, okay? Also, maximums, okay? Did I change direction at 1? Yeah, why? Because I'm flat, velocity 0, I just stopped. Am I flat here at 3? Yeah, why? Because my velocity 0, I just stopped. Okay? I also have to be able to look at the velocity function. Ooh, I stopped there at 0. I changed direction. I changed direction for more than just because I hit the x-axis, because I had a change in sign. Okay? We'll get to that. But the last thing that we're going to do is check this out. What can we infer? Okay, not sure if it's the right words or not. From velocity. Well, what can we infer from velocity? Well, we know based on if velocity is positive or negative, that gives us direction. Positive or negative gives us direction. Okay? Meaning positive moving right, negative moving left. Okay? Or when I'm looking at the graph, towards x-axis, slowing down. Okay, gives us direction, and if it moves away from x-axis, I'm speeding up. What does the acceleration give me? Looking at the accelerator, there's the acceleration graph, it's pink. The acceleration graph is always increasing. Let me tell you, the acceleration graph alone tells us nothing. Alone, acceleration doesn't tell us squat. Okay? Positive, negative gives us direction for a value of velocity towards x-axis. The graph, if it's moving towards the x-axis, that tells me I'm slowing down. Away from the x-axis, I'm speeding up. I don't know why I said duh. Okay? What does the velocity tell me? The velocity here, we'll just look at it. Here's my velocity curve. Well, across that whole interval, I slowed down and I sped up, looking at my position. So just looking at the acceleration graph tells me nothing. Okay, so what is it good for? Well, let's check out. Let's compare some graphs here now. Okay, what do you notice about the intervals of speeding up and slowing down, and the intervals of positive, negative between velocity and acceleration? So what these all have to do with here, I got 0, 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1, 0. And
and we're going to compare velocity and acceleration. So, between 0 to 1, my velocity here, okay, function's increasing, it's positive. I know my velocity is positive, and I can see my velocity is positive. Then, between 1 and 3, okay, between 1 and 3, my function's decreasing, which tells me between 1 and 3, that tells me if my function's decreasing, velocity is negative, and I can see on my velocity curve, I'm negative. Okay? I don't like that. I gotta make that a little nicer. So I can see between here and here. Okay? Now, what else do I see? Well, from 3 all the way to 6. Well, position's increasing. Huh, that means my velocity is positive, doesn't it? Oh, look at there. My velocity curve's above the x-axis. Well, isn't that kind of a sweet deal? Well, let's look at the acceleration now. Let's look at our acceleration. Well, here's my acceleration graph. Well, from 0 all the way to 2, from 0 all the way to 2, my acceleration is negative, isn't it? And then from 2 all the way out to 6, my acceleration's above the x-axis, therefore it's not 1, it's positive. What does that tell me? It tells me quite a bit, really. Okay? What it tells me is it confirms a little bit that we did. Now I don't even need to see the graph. Okay? When I'm looking at this, from here I had a chain. Whoa, I don't want it that fat. I want that skinny little guy up there. Maybe not there. Okay? There we go. So, what am I going to look at? I'm going to look at a few things. Well, check it out. 0 to 1, okay? We knew from 0 to 1, we were slowing down. We were told that in the beginning. We got that. Then from 1 to 2, we sped up, didn't we? So, I need to get, and from 1 to 2, between here, we sped up. And then didn't we slow down again from 2 to 3? I think we slowed down from 2 to 3, didn't we? So then we slowed down, okay? And I really don't like the way I'm doing this. So I'm going to go, come on, baby. I'm going to back this up, sorry. So I'm going to throw all these down here. We said 0, 1, 2, 3, 4, 5, and we come back on 6. I know from 0 to 1, I was slowing down. Then I sped up. Guess what I did now? I slowed down again. And then from 3 all the way to 6, I sped up, didn't I? Well, let's look. Why? Why was I speeding up? Why was I speeding up from 0 to 1? Well, check it out. Or, excuse me, why was I slowing down from 0 to 1? Well, my v of t, what was it? It was positive. What was my acceleration? My acceleration was negative from 0 to 1. When did I speed up? When I sped up, v of t, what did that equal? Ooh, now I was negative here. Here I'm negative. v of t was negative. What was my acceleration? A of t was negative. Look at there. That was negative as well. Then, from 2 to 3, v of t, what was my v of t? 2 to 3, I was negative yet. How about my acceleration? I'm kind of thinking, if I was slowing down, I'm kind of thinking, look at there, it was positive. And then from 3 to 6, v of t, what was my v of t from 3 look at there, it was positive the whole way. A of t,
What was A of t from 3 all the way to 6? Ooh, it was positive. Well, connect the dots. You're not always going to have graphs. Sometimes you're just going to have the function where you're going to have to find time intervals and test those time intervals like we did to find the sign of velocity and acceleration. And when I speed up, whenever I sped up, okay, notice I sped up and I sped up. What did I notice? V of t and A of t were the same sign. That meant they were working together. Okay? When were they slowing down? Well, check it out. When were they slowing down? I slowed down here, velocity was positive, acceleration was negative. I was slowing down here, velocity was negative, acceleration was positive. But bottom line, when V of t and A of t are different signs, or difference probably not the best word, opposite signs, what's happening is velocity and acceleration are working against each other. Okay? And when they work against each other, they slow down. When they work simultaneously together as a cohesive unit, they speed up. And that's the end of today's lesson. I hope your headache isn't too bad. I hope it went rather smoothly, and I hope you understood it. So I hope you also have a great weekend, and I will have something for you on Monday.